Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to present our project titled BudgetWise. It is a smart budget planner using greedy algorithm. Before we dive into the details, let me introduce myself. My name is SOFEAH BINTI ASMAN, and my groupmate Nina Syahira binti AZMAN, and also SITI RAIHANNAH binti Muhammad NAZRUL. The contents for this presentation will consist of the first one, introduction, and then design overview, code explanation, testing and execution, comparison with existing algorithm, and lastly, conclusion. The theme that we decide to focus on is financial management and empowerment. For problem statement, it is because the lack of comprehensive tools that track expenses effectively, provide actionable insights, and lastly, to help achieve financial goals. And the objective for this algorithm is to categorizing expenses, optimizing savings, setting monthly goals, and lastly, predicting spending. For design overview, algorithm that we use is greedy algorithm. It optimizes expense allocation by addressing high priority expenses first, and some interactive element inside the program includes financial mission to encourage additional savings. And the flow of the program will start with collect user inputs and then calculate expenses and savings. Next, optimize allocation using greedy algorithm. And lastly, distribute savings across category.
Assalamualaikum, my name is Siti Nurahana, metric number 2219358, and I'll be explaining regarding the coding for our budget using greedy algorithm. First thing first, we need to import NumPy as NP, where this line imports the NumPy library, commonly used for numerical computation in Python. And also we import the random library, which is to generate random numbers. This is used for later in suggesting a financial challenge. So the first function is the get user input function, where the functionality of this function is the core of the program's data collection. It will ask the user to input certain things, then uses a series of while loops and uh, to gather the following information such as the monthly income, the list of expenses, each with a category, cost, and a priority, and then monthly saving goal, and then saving category with percentages of allocating savings. And as for the error handling, um, we extensively uses a while loop and try accept block to validate user input. Income expenses cost saving goal, where it ensures these are positive number, catching value error. If not, as for the expense priority, it verifies the priority within the range of 1 to 10. We'll also be using try except for value errors. For the saving categories percentage, it checks the total percentage for saving categories, which sums to 100, prompting the user to re-enter values if necessary. Then, as for the next function, which is the calculate savings function, where it takes the income and expenses and calculates by summing up the cost of all expenses. As for saving, it subtract the total expenses from income. As for the error handling, it relies on the validation done in get user input and doesn't have its own explicit error handling. Next, here is where we have used the greedy algorithm, which is to prioritize and allocate the budget. It sorts the expenses by priority, which is the highest first, and it iterates through the expenses, allocating funds until income is depleted. The error handling in here is similar to calculate saving, where it depends on the input validation from get user input. Next function is the mission for extra savings, where it adds a gamified element uh, in presenting a random financial challenge, which is like a mission for the user to do in order for them to earn extra income. So if the user indicates that they have completed the mission, it will calculate and return a bonus amount. If it's not, it returns zero. So the error and handling here is not using try except, it handles the case where the mission is not complete by returning zero. Next function is the distribute saving function, where this function is to calculate the saving and the user define saving categories. It sorts the saving category by percentage, highest first, and calculate and allocate saving to each category based on its percentage, and print a breakdown of the distribution. As for the error handling, it relies on the validation of get user input to ensure saving category percentages are correct. And lastly is the main function, uh, where the function orchestrate the entire program flow, where it calls function to get user input, calculate saving, allocate budget, present the challenge, and also distribute saving. It also prints a summary of the user financial situation. Um, yeah, that is all for the good explanation. So next we are moving on to the and the expected outcome. So after we have run the program will ask the user to enter monthly income. So let's say the monthly income is 2,500. 2,500. Then the program will ask to enter an expense category such as so first we do car. Whereas for car, the user will need to use 400 ringgit. And then next category is rent. Oh, the enter priority for the car. So we need to choose between 1 and the 10. 10 being the highest priority. So let's say for car it is 6. Oh no, 8. The priority is 8. And then we can go ahead enter a new expense category such as rent. So let's say rent is we need to pay 1,000, and the priority rate is a 10, which is the highest of the priority. Next is food, such as let's say we spend 600 ringgit for food, but the priority is around 6. And then if you're done with categorizing the expenses, we can go ahead and type done, and then enter monthly saving goal. Let's say every month we want to save 400 ringgit. And then enter saving category. So here we can have a lot of categories such as for marriage, to get married, and then how many of the percentage of the income ataupun or the savings, out of 100%, how much we want to allocate, how much percentage you want to allocate from saving to save in that specific category. So for marriage, let's say it is 30%. So the program itself will tell the user how many percentage left that they can allocate. So next category, let's say our scholarship or GPA that we need to pay back. So around 20%, we would like to save about 20% to that saving, and we are left with 50%. So with the remaining, I would want the savings to go to in categories such as the parents. Um, so around 50%. So it will automatically go to the mission because the percentage has been fulfilled, which is already 100%. So the user can no longer input any more percentage. So here, the output, there is a summary. Total income, which is 2,500, total expenses 2,000 when we calculated all the expenses. Then the current saving, it is 500, and then the total saving percentage from income is 20%. So here is the private expenses. This we use greedy algorithm, where the highest priority is going to be the first one, and then the lowest is going to be the food. Then congrats, you've already met your goal, saving of 400 ringgit. So from the current saving, if we deducted the income with the expenses, we actually got 500, and it actually fulfills the saving goal of 400. So next, this is a mission which is for the user to complete in order to get an extra saving. So complete financial this. So this will be executed randomly. So for every time it's executing, there's a new mission. So let's say we say yes. Uh, the mission is completed. Then the RM10 ringgit bonus will be added up to the distributed saving across category. So here we have also used the greedy algorithm where the highest of the percentage will be the top. and then the lowest of priority will be at the bottom. So that is all for the testing and execution. The top, and then the lowest of priority will be.
Next, we will see the comparison between assisted algorithm and our algorithm in the budget planning system. So here we got it from research and article that were written by Wang and Shi in 2014 and by Lee in 2022. So here we can see the feature that is budget planning algorithm by Wang and Shi and Lee L. So we're gonna go to purpose, personal expenses tracking and saving for budget planning algorithm, and for Wang they do the job scheduling in clouds, and for Lee they do multi-agent task allocation. So for methodology, our algorithm do the greedy allocation and user defined input. You can see the difference here when we do the user defined input, while Wang do the greedy scheduling and Lee do utility to cost ratio optimization. Bear in mind that our comparison is based on a budget planning system. And the adaptability for budget planning algorithm is static income and expenses by Wong, dynamic cloud cost adjustment, and by Lee, dynamic task and cost change. And for priority handling, our algorithm choose the user defined priority levels, and by Wang they do the task specific priorities, and by Lee they do the utility driven allocation. And the best one is our complexity for the algorithm is low, while Wang and Shi is moderate, and the last one Lee is high. Here, I will provide the notable strengths of the budget planner algorithm. The first one is accessibility. The straightforward nature of the budget planner make it user-friendly, especially for individual unfamiliar with complex computational system. And the second one is savings distribution by allowing users to define savings categories and allocate percentage. The algorithm supports personalized financial planning. So the last one is interactive features. When the inclusion of a mission for extra savings feature introduce gamified elements, encourage better financial habits. This approach makes budgeting more engaging and is a unique aspect not found in other algorithms. So for the conclusion, this project demonstrates the potential of greedy algorithm to create a robust and efficient personal finance management tool. By enabling users to categorize expenses, optimize savings, set financial goals, and predict spending pattern, the algorithms address key challenge in managing personal finance. And the use of a simple yet effective computational techniques, making it a comprehensive solution for financial empowerment. I think that's all from us. Thank you.